evening, guys. How's it going? It's the weekend, yeah, boy. Hope everyone's had a good week. I literally just turned the PC on, so let's just go through all the cameras, make sure we're all up and running. Turn on my little slide buttons here. Start that. So camera 1, camera 2. That's working straight away. That's good to see. Let's get the scope cam up a little bit. Camera 3 scope cam and power supply cam. How are we looking? Oh, not too far off. It always gets knocked, this one, so it's always a little bit out sometimes. Almost there. It's not bad. That'll do. Power supply cam, yep, all good. And then we've got the far cam. What's up, guys? And then we have the hat cam. Hat cam is up and running as well. Nice and easy start to the stream this evening. Right. Okay. Hello from Vegas. How's it going, buddy? Alright, so the plan for this evening is I want to crack on and hopefully sort out finally find the problem with the Rockford Fosgate 4 channel, hence the title. So Rockford Fosgate 4 channel we've been working on for weeks now. I say weeks. Like I've probably done like 3 or 4 hour sessions of it. Just a few sessions trying to get up and running, and I think we finally found the cause of the problem, we think, but we're not sure, so we're going to find out today. So let's just get this Alpine off the bench, and then we can get the Rockford on there and crack on. G'day guys, g'day, thanks for jumping on the stream. DJ Rockon was like, just watching one of your old videos. Oh, which one were you watching? Which one were you watching earlier? Right, so let's take this Alpine off the bench, put that back over here. And let's get Rockford. Okay. Hello from Finland. Yo, Pekka, how's it going, buddy? Thanks for jumping on. Okay. So, going to get some power wires going into this Rockford, and I'm hoping that this will be the last stream we do on the Rockford, because I'm hoping that we will be able to solve this evening. The last stream we did on this one, we did some swapping round and some removal of some components on 2 driver cards. One driver card that was known working, one driver card that we knew was a problem, and we actually managed to get the problem driver card out of protection mode finally. So we think we know the area that the problem lies. We just need to try and hone in on it and just basically replace the components that we think are going to be faulty to get it up and running again. The Atomic 5000.1 with the messed up power supply. Oh, okay, yeah, that's quite an old video now, I think. Get that around that orientation, get that down there. Zoom in a little bit on the drive cards here. Okay, so this was, yeah, so if you remember from the last stream, which you may or may not, I don't know if you were there or not, the last stream, this is the output driver card from the Rockford 4-channel class AD. So it's basically a 4-channel class D, the Rockford own design, and there was some problems with the protection circuit. Basically, one of these cards was throwing the amp into protection when there was no need for it. There's nothing wrong with the amplifier, just a protection circuit fault. We managed to get the amp out of protection by removing a couple of op amps here on the driver card. There was a TL074C and an 833, an LM833 just down here below it. Removed the both from here, so there's a few things that we need to do now to go forward. We have the original op amps that I took out of these cards on the bench here, sitting right in front of me, so we can swap them round. But we were taking some voltage readings from these two cards of what the voltages were on these pins, on these pads here for these op amps. They were all completely different between these two cards, meaning that there was definitely something funky going on. So now we've removed the op amps and the faulty driver card has come out of protection mode. What I want to go ahead and do is actually power these up again and confirm what voltages we have on these pads with both of these op amps now removed. So I think that's the first thing that we're going to do, because that will tell us whether there is perhaps other issues elsewhere on the card or whether it's just the op amp that was bad. I'm hoping and praying at this point that the voltages on both these cards, on these pads, are equal. If they're not, then there's more bad components on this board that we're going to have to try and find that are very difficult to actually come across. So let's get the power supply turned up a little bit here, 9.6 volts, nice and low, don't need that much current. We're just looking for some small low voltage stuff on these op amps here. So I'm going to go ahead and get this fired up now, get it powered up, and we're going to I'm going to open some Notepad on my PC here. I think I've got the file from the one I did before, because I had some 1001 pins. Here we go, Rockford 4-channel op amps. I've got a little Notepad thing here on the screen. You can see there. So down here we had a bunch of here we go, U8 and U4. So with them out, U4, I'm going to go out. I'm going to do some. Actually, you know what? This is U4. Let's do it again. U4 no part, and then 1, 2, 3, 4, 5, 6, 7, 8. And then we can work out what voltages need to go in there. So, okay, let's power up then and see what we have. This is on the bad driver card, the one that was faulty previously. So, just going to go ahead and power her up now. Make sure that this is all still in there, nice and tight, and that should come to life. Go 1.6. Okay, interestingly, this channel still isn't coming to life just yet, even though it did last time. Last time it did. Oh, this is really weird and annoying. So the last stream we did, the bad driver card with the op amp removed did actually come to life and start switching. So why is it not doing that today? Huh? Well, why are you not doing that today? The other channels are active, so why are you not active now? Oh man, so it's changed since last time. Okay, well we can check on Q52 here, because this is the shutdown signal that's supposed to be sent to the IC. So let's have a look. Okay, it does pop up to negative 27, so that is actually telling the chip to activate. There we go. Okay, so it just needs a little bit of kickstart from some signal. Okay, so that's working fine. So I just wanted to double check and confirm that was still working fine with the op amp removed. Right, now let's start reading off some voltages. So I'm going to go pin 1 here. So pin 1 on the TL072C location with the part removed. What do we have? So we have 9.6 up to 11.4. So 9.6 up to 11.4. So I'm just making a note of these. Then we're going to go for pin 2. Pin 2. What do we have on pin 2? Couple bumps. And then nothing. Okay, so a couple bumps, not really anything, just 0 volts, just a couple of sort of little pulses. Okay, pin 3. Up to 4.7. And then no change, so 4.7 steady. Pin 4 is VCC, don't need to check that. Pin 5 then, what do we have on pin 5? Negative 5.5 steady. When we first, yeah, negative 5.5 steady. Pin 6. .7 steady. I actually need to move those down a bit. Minus 5.5 and 0.7. So pin 7 now, which is the last one we need to test because pin 8 is going to be VCC, which we don't need to worry about. So pin 7 is again 0.7 steady, doesn't change. Okay, so that's the bad one. So we have now listed out all of the voltages here on U4 with no part fitted, no actual chip fitted. So what I'm going to go ahead and do now is wait for the rail voltage. Just going to kind of short out the rail capacitors in this to get the voltage dissipated, so that there's no rail left in the board. And then we're going to go ahead and mount the good known working driver card in these headers instead, and then compare the voltages just to make sure they're the same. I really hope that these are the same, because that will mean that there's no further issues on the bad driver card. So I'm literally hoping and praying right now that we get the exact same results, exact same voltages on this one now with these parts removed. What's up, guys? Thanks for jumping on the stream. Hello Sean, Sergio, just me, Ernard. Thanks for jumping on the stream, guys. Keeping me company on a Friday night. Hope you're all good. Hope your week's been alright. Okay, so this is the known working driver card now fitted. So I'm hoping and praying that we get the same freaking voltages there. And any that are different, then we're going to have to trace back where they come from and try and find faulty components with where those come from. So let's start her off with pin 1 then. Pin 1 was 9.6 up to 11.4 on the originally bad driver card. So let's go here, pin 1, and pray that we get the same. 9.5 up to 11.4. Yeah, that's exactly the same. Fantastic stuff. Okay, good. Pin 2. We're looking for just a couple of bumps. Okay. Yep. Looking good. Just a couple of bumps. Doesn't really do much after that. Just up to 0.7. Okay, that's also the same. Fantastic. We're doing good so far. Pin 3. We're looking for 4.7. 4.7. Steady. Yes, that is the same as well. Awesome. I'm feeling good about this so far. Okay, pin 4, we don't need to worry about. Pin 5, we're looking for negative 5.5. Oh, okay. That's different. That is different. Okay. So, okay, we are 0 volts. Shit, okay. So there is still a fault on the other driver card then, because pin 5 is very different. Pin 5 on the faulty driver card was bumping down to negative 5.5. So we're going to have to trace back and see where that comes from, what components are attached to pin 5. That's the only one that I've seen so far that's different. Okay, pin 6, let's keep going. We're looking for 0.7 volts on the bad card. 0.7, yeah, that's correct. Amp activates, that's correct. Okay, pin 7, sorry, pin 6 that was, pin 7, this is pin 7, 0.7, steady. Okay, right, so they weren't exactly the same. Pin 5 is the problem on this bad driver card, which might mean that the actual TL074C was actually okay. Probably going to replace it anyway, is it while it got damaged, but whatever is connected to pin 5 of the TL072C is a bit of an issue on this bad driver card. So we're going to go ahead and investigate now on that and see what is connected to pin 5 on this driver card to try and hone in on where the issue lies. Okay. So, get the whole multimeter. Why do I never get multimeter camera come up when I first start streaming? Let me see if I can get that up and running now. Deactivate, activate. It should come alive now. I need to change the battery in this multimeter. Come on. Oh, green, green. Come on, you can do it. Make a connection. See the green square there? That's supposed to be my multimeter camera. Come on. It's kind of important that you see the multimeter on this one. Oh, there we go. Oh, she's glitching, she's glitching. Yeah, there's like a really dodgy USB cable or something. Yeah, it's heckin' dodgy as fuck. What the heck? Oh, fuck's sake. Come on, bro. Come on, bro. Okay, we're gonna have to give up on that for tonight. I have to fix the wire. So, you're just gonna have to listen to my call outs for the multimeter. Okay, so where are we connected to then? Pin 5 of the TL072. What is this connected to now? We're gonna see if I can actually see the trace, where that trace goes on here. But like this kind of board is like black, so it's very difficult to actually follow traces on this. You can't really see the traces that easily. I'll take some isopropyl alcohol, see if that cleans up a little bit, so it makes it a little bit easier to see. Okay, so I can see here that it goes through a via to the other side of the board. There's a little via there. So it goes through the board, and there's probably a bunch of components on the back here. So what I'm going to go ahead and do is just scratch away the laminate slightly on this via where it goes through, so that my multimeter makes a connection. So I can just kind of hold it in this little hole here. Okay, there we go. So that's making continuity now. So if I flip the board over, keep it in the hole, we should be able to find what that connects to on the other side. I'll zoom out a little bit. So stick the multimeter in there. There we go. Okay. Right, what are you connected to over here? It's got to be one of these little transistors on the back here. See, it's like a bunch of transistors over here. Q21. Okay, not seeing it. See if we can see the via on the other side of the board and follow it. It's like there. So it should be Q29 by the looks of the position of the via. Although I think this board is like triple layer, so it might not even be that. It might be this one. Are there any good books for amplifier repair, Sam? Says DJ Rockon. Yeah, you need to download Perry's Guide from bca1.com. That's what you need to do. Okay, this is weird. So that via on the top of the board doesn't seem to connect to anything on the bottom here. I wonder whether the via itself is bad or whether it's just a multi-layer PCB. And that it's going somewhere else, like, you know, along the insides of this board and then coming back out on the top somewhere else. I might need to go ahead and take the good board as a reference. So you see the good board that's in here, I can do the same thing and check for continuity between that pin there and the other side of the board, just in case maybe there is like some broken trace or broken via on this board which is causing that issue there. I'm just trying to see if I can find any continuity to anywhere else on this board. Any of these pins? So it's got to be on the other side of the board then. There's got to be continuity somewhere. Maybe that's the issue. Maybe there just isn't. Maybe that's because this via is bad. Ah, I found something over here. There's something over this side of the board. Okay, here we go. So we have continuity to R15, which is like a 10K by the looks of it. Is that it? Any continuity to anything else? Looks like that via goes all the way through the centre of the board there, comes out at that resistor. Okay, so now we have somewhere else to probe. So what we're going to go ahead and do is do the same thing on this this working driver card here, and just confirm that that's the only part that pin 5 of the TL072C has continuity to. So if I scrape off the insulation on this one as well, so we can get our multimeter in there. Okay, cool. So we put our multimeter in there, like we did on the bad card, pin 5, and I'm just going to go ahead and check for continuity anywhere else on the board here, on this side. Just trying to take a quick little brush over. A little metal brush, actually, like a wire brush, would be amazing for this kind of thing, where you just want to brush over the entirety of the PCB, looking for continuity. Like a little metal brush connected to the multimeter would be really, really useful. I've seen some other technicians do that as well, actually. So now if we go on the back side of the PCB, we had continuity over here to R15, which we do, but I just want to double check to see if we have any continuity to any of these transistors over here, because that kind of seems to be where it goes into the board, that via. But I think it might just go into the via and come out over the other side. It's like triple layer, this PCB. You now do what Lewis Rossman did back when he was focused on board repair. Yeah, I've noticed this, right? So I started watching Lewis Rossman years and years ago, and that's actually kind of what got me confident in board repair. Watching Lewis Rossman, like watching his videos, there's water continuity to this capacitor. He actually got me kind of confident with board repair and soldering techniques and stuff like that. And unfortunately, yeah, now a lot of his videos I'm just not really that interested in watching. It's all about politics, all about complaining, it's all about right to repair, which I get. Like, a lot of the information he says is probably true. Like, I've no idea if I would agree with everything that he says because I don't watch the videos, but like, he seems like an honest, genuine, nice guy, and you know, he's just a businessman. He's a repair tech. I think we have very similar like thought processes in terms of repair anyway. So yeah, I would definitely love to sit down, have a beer with him and stuff, and you know, chat about stuff. But yeah, the videos, like, I'm not super interested in watching those kind of videos where it's just talking about stuff. I want to see more board repairs. But that's just me because I'm a technician, so I get why he's doing that, because I think those videos on his channel do better than the board repair videos. Like, the board repair videos were always just kind of like a thing that he did while he was talking about shit problems with the world and stuff, and so I think he's just focusing on that just because that's where the channel wants to go. You know, that's where the viewers want to see. It's what they want to see. So, okay. So the good board then confirms that we don't have continuity anywhere else. Any of these transistors directly under the via. So the via must be going through the multi-layer PCB all the way over here to R15 and to C3. Okay, so let's just confirm that on the bad board that we do have continuity to R15 and C3 both together. R15. Yep. C3. Yep. Okay. Cool. So one of these is the problem then. We need to find out where that -5. What the heck? my Google Home on my phone has decided to tell me Portuguese. So in English. All right. Thanks for that, I guess. So, okay, yeah, we need to go ahead now and plug in both of these cards, the good one and the bad one. We need to find out where this rogue -5.5 volts is coming from on the bad board, because that's what's giving us some grief over on the TL494. On the TL072C. So let's go ahead and plug her back in. This is the bad PCB now. This is the bad driver card. So we're going to plug her back in. Fisher says, "My name is John." Wow. Thank you so much, buddy. That's awesome. Hi, John. Thanks for jumping on the stream, John. How's your week been, John? Oh, I've just realised he's replying to Paul there. Is your name Cody? I thought that John was just came in and just announced that his name was John for the lols. Okay, so the bad board is now back into the headers, so we're going to flip her over. Yep. Nice. So now we have the back side of the PCB with those components that we want to check out. So remember, we had continuity from pin 5 of the TL072C to, it was R15 and C3. So that's this one here and this one here. So we have -5.5 volts coming in where it shouldn't be coming in. So we're going to go ahead and power the board up again now and figure out whether it leaks through the cap or whether it comes through R15. So, oh sorry, yeah, R15 there. Okay, so we don't even have to let the amp power up fully. It just jumps straight to -5.5. You can see that. So let's go the other side of R15. R15 is a pretty high value resistor. So if we go on the other side of R15, what do we have? We have -5.503, -5.5. Oh, holy shit! It's gone down to -9. Right. So it's not coming through R15. The reason we know it's not coming through R15 is because the voltage is higher on this side than that side. So perhaps. Oh, actually, no. Hang on a minute. What am I saying? Maybe it was that side of R15. Yeah. Maybe it was. Maybe the voltage is coming through R15 then. Okay, let me just quickly double check this. So C3 is what we had continuity. Let me get the good board over here and just have a quick check. So this is the good board. I just want to double check what one it was. Was it which side of R15 it was? It was. Okay, so it's the low side. Okay, so it's the bottom. When I'm looking at it here, it's the top side of R15. So okay, so top side of R15 should be -5.5, which is this one here. Okay, so that should be -5.5, which it is. Right, so the voltage is coming through R15 then, because on the other side of it we have a higher voltage. We have -9.6. which is more like a kind of VCC. So there's definitely some leaking component there. I'm just going to go ahead and quickly double check C3. I want to make sure that we haven't got voltage coming through C3. If we check that, that's negative 5.5, and on the other side we have 0 volts. Okay, so that then confirms to us that the issue is coming through R15. So we need to find out now what is connected to this side of R15, because that has negative 9.6 volts on it, which should not be there. Okay, turn the power supply off. Let's drain the rail caps so that we don't have high voltage rail sitting there anymore. What's going on with this head cam? Come on, focus. There we go. Short out these caps. Okay, jump back on here. Multimeter. Right, R15. What are you connected to, my friend? Where do you go? Do you go somewhere nearby? Do you have a via connected right up next to you? Okay, looks like R15. Looks like you go over here. Yes, you go to R109, and you also go through another via. See, there's a via here. You can actually see that on the screen there. We've got a connection there to R109, C10, and also goes through to the other side of the board. Okay, so the first thing we're going to do then is power it back up, and we're going to see whether we have the voltage coming through R109. Remember, every time that we go through a resistor, so we're working our way backwards, we have negative 5.5 where we shouldn't have. We found a resistor that has negative 5.5 on one side and negative 9.6 on the other side. So we know that that voltage is leaking through that resistor. So that now we know that's the correct path. So now from that resistor, we need to find out, we've got 9.6 volts, negative 9.6 volts. We now need to find out what component has negative 9.6 volts on one side and either negative 9.6 on the other side, or even more, negative 10, negative 12, negative 15, something even greater on the other side that's coming through. So we have this resistor here, which is R109 or R27? Because there's two markings there. I think here we go. R109 is this one, so it's R27. Okay, cool. So let's power it up again, and let's see what we have on either side of R27. Okay, so R27 we have negative 9.6. On the other side we have a negative 5.5. Okay, so it's not coming through R27. Is it coming through C10? No, we have 5.5. So the voltage gets less on the other side of these two components. So it's not coming through those components. So therefore, it must be coming from another component that is through this via. So we're going to go back, flip over probably to the other side of the PCB now. This is like a wild goose chase here, finding out where this voltage is originating from. Okay, so we know it's not coming through there. So first I'm just going to go ahead and do a quick brush of this side of the board to see whether there's any other components on this side of the board that's connected to. Because even though there's a via there, it might just be that the via is connecting to some other part on this side of the board, just like, you know, just to get the trace nice and easily there. This is one of the reasons why it's so important to have a multimeter that gives you an instantaneous beep when the probes are touched. Some cheap multimeters, or even actually some expensive multimeters, will have a slight delay between when the probes touch and when it beeps. This is why it's so important to have one that doesn't beep. It doesn't have a delay, sorry, on the beep. Right. Okay. So I think that the component is on the other side of the board. So flip around again. We're going to have to scratch away at that via so we can stick our multimeter in there. And that's this one here. This is a wild goose chase, my friends. Okay, cool. So it scratched away that little trace there. So now we can shove our multimeter probe in that hole for that via, and then flip the board over and find out where else it goes. So I'm going to actually remove this from here just now, so we can figure it out a little bit easier. On there. Okay, so where do you go then? Where do you go now? Okay, seems to come from actually an op amp over on this side of the board. Aha, pin 7 of whatever the heck this op amp is. Okay, so likelihood is that this op amp might be dead. This is a wild goose chase. So we need to go ahead and remove this op amp now. See this one here? What's that? U11. We've got to remove U11. And see what that is. So I'm going to go ahead and remove U11. I might even remove U11 on the good card as well, so that we can compare all the voltages up to U11. Holy bananas. Alright. Okay, I guess we're removing U11 because that's where that -9 whatever it is voltage is coming from. Is U11 even, what is that? What is U11? Hello Annabelle, how's it going? Anonymous Repair, how's it going? John says, I'm a long time watcher. I've learned a lot from watching you. Thanks for your informative videos. No problem at all, buddy. I'm really glad that you find them interesting and informative. I cannot read this. I think this is another 833, LM833, I think. Yeah, this is a LM833. So there's been a few LM833s on this board. I'm hoping that I can substitute that with something else that I've got in stock, because I don't stock LM833s. I'm wondering whether I can use something else that I happen to have in stock, like, I don't know, a 211, 311, I don't know, something along those lines. Maybe like something else I've got laying around, maybe. We'll see. Okay, so let's get the hot air gun turned on. We're going to go ahead and remove that 833. And next to it is another 072C, so we're going to go ahead and remove this and see what the jam is. This thing is putting up a fight. It is, but it is being very interesting. I'm learning this circuit very, very well, like, now. So, you know, next time I get one of these in, if it's got issues with this drive card, I'll be a lot more prepared to deal with it. So that's pretty cool, I guess. Where are my tweezers? Where are my tweezers? There they are. Okay, so to remind myself, I'm putting the LM833 from the bad card. I'm putting it over on the right hand side of the bottom shelf. Now I'm going to go ahead and remove the LM833 from the good card, I think. Or perhaps, should I do that? I don't know. Yeah. Should I do that yet? Yeah, fuck it. I like watching the whole repair process. Keep it up. Thanks very much, man. I'm glad that you enjoy watching the whole repair process. I do worry sometimes that this gets kind of boring because, you know, this is a long-ass repair. Been quite a few streams of this one already, but it is an in-depth one, and I do enjoy doing these. I get great satisfaction from actually, you know, figuring out the problem and fixing these, so I hope that you do get some satisfaction from watching the process as well. Okay, and I'm putting the 833 from the good card on the top shelf on the right hand side. So good card top, bad card bottom. Okay, let's isopropyl that off a little bit just so that that's nice and clean for the oscilloscope probe. There's the good card and the bad card. Okay, let's connect these back up. Ah, shit, which way around does this go? I think we are this way around, aren't we? Yes, we are this way around. Yes. Try it without the chip to see what it does. Yeah, my friend, that's exactly what we're doing. We are powering it back up without the chip to see what she does. To see whether that negative 9.6 volts has disappeared from where it shouldn't be. And I'm hoping that we're now going to get equilibrium between the bad card and the good card. Okay, so that's all hooked back up. So let's power her up and see. I think we are the wrong side of the board, so flip that around, just like that. So it was pin, shit, can't remember what pin it was. Pin 6, pin 7? Which pin was it that was connected to that part on the other side? R15. R15, you're connected to pin 1, 2, 3, 4, 5, 6, 7. So it's the top one on the left. Top second on the left. 1, 2, 3, 4, 5, 6, 7. Pin 7. Up there. Okay. So it's this one up here. This is the one that was causing problems before. So let's now make a note on our notepad of the voltages on each of these pins on these pads. Now we have that 833 removed. So this is U11. U11, no parts. We're going to go 1, 2, 3, 4, 5, 6, 7, 8. So now let's get her powered up and see what we have. Right, pin 1 then. Now I don't need to fully power this thing up now to get the Class C switching coming in, I don't think. Okay, so pin 1 we have negative 5.7. This is the bad card, remember. So we have negative 5.7. Okay, pin 2. Negative 11.5. Pin 3. Negative 3.1. These are some random ass voltages, man. Pin 4 is VCC. Pin 5. Negative 11.9. I think that the 072C next to it is dead. There's like a lot of negative random voltages here. Pin number 6. Negative 7. Pin number 7. Shouldn't be anything. Oh heck. Negative 6.5. Wait, what? How? Okay. And 8 is VCC. All right. Let's now plug the good card in and compare. I'm a little bit confused actually how pin 7 still had negative 6 volts on it. I know it's not the same. It was negative 9, wasn't it? It was negative 9 before. before we took the chip out, but so that there's still voltage coming through from somewhere, but maybe it's correct. So we're going to go ahead now and put in the good card, the good known working card. So let's see if we have differences. I think we're still going to have differences, and I think that the TL072C next to it is going to be problems as well. I think we're going to have differences in voltage on that one. So I think we might need to just go ahead and remove that one. So let's go ahead and power it up again. Then we're looking for pin 1. We're looking for negative 5.7. Negative 4.4. Okay. Yeah, I think there's, so negative 4.4, good. Pin 2, we had negative 11.5, negative 8.8. That's pin 3 then, negative 5.9. Holy shit, they're all fucking completely different. Pin 5. Negative 8. They're all over the place. They're nothing alike. Pin 6. Negative 13.7. What the hell is going on? How many parts on this board are toast? Pin 7. Negative 13.7. Holy shit. There is so much difference in it. Look at the differences. So this is the good one, and this is the bad one. Fucking hell. Where's all this nonsense voltages coming from? Okay, let's just do a quick check and see what's on the 072C, because I might remove that next. So pin 1 we have just like a what's pin 1? Pin 1 we have not much, a couple of bumps. So bumps, 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 VCC, bumps, bumps. So 4.5 is the only voltage we should have on the 072C on pin 7. Okay, so that's cool. I'm going to go ahead and plug the bad card in now, and if there are any voltages on any pins other than pin 7, we're removing the 072C. Get it back in there. So remember, we're looking for nothing on this 072C other than pin 7. That's good. 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 4.5. It's 5.8. But okay, so at least that's fine. So at least the 072C isn't leaking and shit. So okay, well, I guess we're gonna go on another wild goose chase then to figure out why we have such crazy random different voltages on this chip pad location. Like what's feeding all of these pins? Like they're so freaking different. So holy shit. Wow. On the bad one, pin 1, we had what have we got? Negative 5.7. Yeah, just making sure these are the same as what I noted down earlier. Just to make sure nothing's changed. 11.4, 3.1. Yeah, these are all the same. 11.04. 11.9. Yeah, so that's all the same. All right. So what I'm going to go ahead and do is figure out what parts are connected to the main input pins and stuff of this op amp, and to go ahead and like run some tests on them and shit. Like I don't know, fucking hell, man, this is getting ridiculous. Wow. Okay. Power off. Drain the rail caps. Okay, so what has continuity then to some of these pins? So we're going to start off with pin 1. What's pin 1 connected to? Anything on the top of the board? Okay, I have this resistor here, R104. I also have R74, this capacitor. We have this one here, any of these transistors. Like the parts that are likely to be bad are going to be like semiconductor parts, like transistors and shit. So I'm sort of seeing what has continuity where in terms of like transistors and stuff. So okay, so pin 1 should have negative 4.4. It has negative 5.7. So I guess we want to maybe see where that's coming from. But let's first of all take a look at pin 2. Pin 2 has negative 11.5. We should have negative 8.8. That's quite a difference. So that might tell us some stuff about what's going on here. Okay, yes. That's okay, here we go. We have something now. So negative 11.5 is on pin 2, which is this one. We have continuity to a couple of resistors over here. Come on, get focused. We have R74. We have continuity to R74. And anything else? It also goes through to the other side of the board as well. Don't seem to have any continuity to anything else on this side of the board. Now remember, we're doing this all without a schematic. We don't have a schematic for this card. Not this deep into it anyway. We've got a schematic for a very basic part of the turn-on circuit, but not this deep. Okay, so other side then. So pin 2, other side, scratch off on this via so we can use our multimeter to go onto the other side of the board. Okay, so I'm going to go ahead and go onto the other side of the board now and figure out what that's connected to. I'm going to go ahead and remove it from these parts here. Okay, other side of the board. We have R109 and R110, I think, is it? Or is that just a capacitance? Yeah, R110 and R109 we have continuity to. Anything else back here? Okay, looks like it's just these two resistors then. Cool. So let's see, what are these two resistors connected to? We've got R109 and R110. R109. I'm looking for some connection to some semiconductor, some like transistor or something, because that's going to be part of the problem. There's something leaking like voltage somewhere. So that has continuity to R113. Anything else? I'm a bit worried because we're getting dangerously close to these tiny little 6-leg ICs. I'm really hoping that these aren't bad because I have no idea what they are, and it means we're going to need to order some new parts. Ah, here we go. We have continuity to this here, which looks like Q48. Okay, Q48. Now we're getting somewhere. We're starting to get towards some transistors. Okay, how about R110? So what's on the other side of R110? Anything? C10, R113. Ah, here we go. Hang on. Okay, that's like a differential. On one side we have, yeah, on one side we have continuity to. Oh no, I was just reading R114, my bad. Okay, so that's not the case. Okay, here we go. We have Q43. Okay, so there are some transistors around here, down this side of the board, and we have continuity there then. So pin 2. Pin 2 on the TL074C, oh no, sorry, pin 2 on the location that housed the 833. Pin 2 has continuity to a few components over here through a couple of resistors that lead down to Q48 and Q43. So I'm just going to go ahead and use my multimeter now to compare some readings between these transistors on the good board and the bad board. Thanks very much to Annibal for the $4.99. That's really cool, man. I really appreciate that. Thanks very much for that tip. Appreciate that. Keep it up. I'll do my best. All right. So I really would love to try and give you my multimeter cam right here. Come on, man. Because I want you to see the values with me, man. Deactivate, activate. Come on, just freaking work. Go ahead and go down and wiggle the wire around a little bit. Hang on a minute. Okay, is it working? We've got something, got a white screen. Hey, there we go. Okay, cool. We're back in business with the multimeter cam. Good stuff, good stuff, good stuff. Right. Okay, so let's go ahead and compare readings on these parts down here then. So we have Q43. Between 1 and 3 we have 803. So that's the bad board, good board. We have 808, nah, close enough. 1 and 2. We have no 805. 802, close enough. And these two, 1133. 11, slightly different there. This is slightly different. Nothing that way around. Nothing that way around. Okay. So we have 800 on the diode next to it. This is a diode, this one, D44 by the looks of it. Or is it Q44? It might be, it's Q44. So, okay, so, yep, that's about the same. 806, 823. 828, close enough. 803, close enough. Okay, 801. Okay, so they're kind of close enough. So let's check the ones down here. Q48. So we have nothing there. So we have nothing, nothing, and this is the good card, by the way. Nothing, nothing, and nothing. So there's no reading this way around. Probably because these are PNPs or NPNs. They're the other versions. So if we look on the bad card, nothing, 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 and nothing. So flip the pros round. We should now get a reading. We should probably get like the 800s again. So yeah, about 800, about 800, about 880. Good card, yeah. Yeah, these are all reading the same, so I don't think that these transistors are the problem. It's something that feeds these transistors. Holy shit. 13, 12. Yeah, okay, so these transistors are reading the same between these two cards. We're getting dangerously close to these little chips. I really hope that these aren't the issue, because I don't know what they are. So we're gonna have to dive in if they are. I'm just gonna do some quick multimeter checks between these to see what if there's any differences between readings on these. So between now these are too small for my multimeter read, so I'm going between many pins here. So I've got 760 between those pins there. Like there's 4 pins that I'm reading there. Oh shit, you know what, they're different. Holy shit. Oh, I think this is, oh no. They're freaking different, guys. Oh my gosh. I think these are the problem, whatever the heck these little things are. Oh man. There's no reading there. This is the good card. Okay, we've got like very, very high value reading there. Right? There's basically nothing on that one. Whereas we go ahead to the bad card. Oh, fuck. No. No. What are these things, man? Holy shit. Okay, what about this top one? Okay, this top one, we're not getting any 1265 on the top set. Okay, 1265 on the top set. 772. Oh man, holy shit. I think, guys, I think we need to remove these chips, man. Like, if anything is going to be dead, like these things are tiny, so if anything is going to be delicate, you know, if anything is going to have a chance of just randomly failing due to some kind of voltage spike, the smaller the IC, the more delicate it's going to be, the more likely it is that that's going to fail. So what we're going to go ahead and do now is I'm just going to unplug my overhead cam. I'm going to go ahead and plug it directly into my microscope cam here, so you guys can get a view through the microscope. We're going to see if we can check out what the heck these chips are, and if I guess ultimately we'll have to remove them, so that, you know, obviously we remove them and we can figure out what the heck they are, so we can actually see them under the microscope, so we can maybe order some new ones if need be. So yeah, fuck. Alright. Okay, let's plug in this here to there. So I'm not going to get my screen, so I have to look at it on the PC. Now if I go to this one here, we're going to have to go ahead and reset this, JVC, deactivate, reactivate, and you should have a view of the microscope. Yeah, okay, so this is the microscope now you're seeing. Okay, let's move our way over there. I'm going to go ahead and rotate 180 so that we're around the right way. Rotate 180. Nice, nice, nice. Okay. This HDMI cable is dodgy as heck. Oh man, it's just labeled 4F. Where's my isopropyl? F, and then on this one up here, 2F. Oh, they're fucking different as well. Of course they're different. Okay, so 4F is down the bottom and 2F is at the top. Okay. Okay. This is the bad card right here. 4F down the bottom, 2F up the top. Right, okay. So guys, I think the next logical thing is to go ahead and remove these two parts from the bad card. I mean, maybe the good card as well, but I think probably the bad card. What I want to do is I want to remove these parts from the bad card here, and then test using the multimeter again. Whoa, okay. Yeah, then test using the multimeter again and see if those kind of low readings that we were seeing on the bad card disappear. Oh, Jesus Christ! What the heck even is this? How am I going to figure what the fuck this thing is? Overbill Automotive says, just watched your Triumph Smart 5 video. You did a great job telling about it. Thanks, man. Appreciate that. Yeah, I worked quite hard on that video. I'm glad that you found it interesting. Alright, so this bottom one, I don't think the 2F was had any problems, did it? I think the 2F wasn't it the same readings on both the bad card and the good card? Let me just confirm that. So the 2F up here. On the multimeter there, got no reading and no reading. And on the good one, we have... You see how freaking small these things are, about how big my probes are. We've got 1286. Oh shit, wait, what the heck? Which card is this? This is the good card. The good card has... The good card has 785 and 1286. The bad card has... nothing. What? Man, what's going on? What's going on? What's going on, guys? What's going on? There could be some transistor that's like opening and closing. I'm gonna go ahead and flip the probes around. 783, 782, 783, 1272. 783, 1272. 784. So okay, cool. Now they're the same. All right. So yeah, there must be some transistor that's like turning on and off or so out there. Right. So that's the same. That's fine. Now this bottom one, just before I remove it, 1275, 772. 1274. Oh, what? Now they're the same. What's even going on here? Now they're the same? What's going on? Seven, 6, 7, 1260. 7, 6, 9. Oh shit, now they're the same. What? Okay, I guess we're going to have to go back to reading voltages then. Abort mission, abort mission. Now they're reading the same. So maybe the voltage is coming from somewhere else. How big is my oscilloscope probe in relation to these pins? What chances do I have of probing these pins without shorting them out? Yeah, I have a relatively good chance, I think, if I just keep it very, very steady. Wow, okay. Guys, I'm just going to go ahead and I'm actually going to change. I think I'm going to change my camera setup slightly here. What I'm going to do is I'm going to unclip this JVC camera from here. Okay, I'm going to go ahead and remove my microscope from its housing here, because this is kind of a bit of a pain in the arse. I'm not going to lie, this fucking thing here with the lights on it. So if I remove that, plunk that down there, and then if I flip this clip over, then I think I can just clip my microscope to this instead, which will be awesome because then I can have it kind of above the desk at any height. I think it's a bit too heavy. I might need to flip that around the other way. So if we flip it around the other way, get a bit more tension in that. And then we've got that there. Get that in there. Like that. Bit more tension. No, it's still kind of shit, isn't it? Okay. How about we do it like... too top heavy, I think, guys. I need like a stronger snake wire here. Nah, it's not going to hold. It's just at some next angle because of how this is here. Okay, like that needs to be like clipping into it that way round, but that's too fat, so abort mission on that one. Let's put this back down, stick you back on the other camera. Stick you back on the JVC so I can work out how the heck that was mounted. How did I have this mounted? I think I had that clamped in there like that. There we go. That was all about there. Put that on there. Wait, how the fuck was this mounted? One sec, guys. try and get this shit mounted back up. Okay. Strict Yams, good evening, guy. How's it going, man? You good? Thanks for jumping on the stream. Did you miss much? Yeah, kind of. Okay, so I need to deactivate this and reactivate this. Power's gone for some reason. Where's the power gone? Seems to have lost power from this camera now. Go back. There we go. Okay, excellent. We're back in business. Okay. Right, so where was I? I was right. So yeah, I think what we need to go ahead and do is we need to go ahead and compare voltages now on these cards at these transistors and these kind of voltage regulator bajubis. Figure out what's going on there. One of those might have failed perhaps. So yeah, no, actually, which way round was these fucking? Wait a minute. Okay, that way. That one goes in there. And the red one. So that goes in there. Like that one. Okay. So that goes in there. Bevis, do you have any other donor boards with the same chips? Well, this amp is a 4-channel amp, so I have 3 other channels with the exact same driver board. So yeah, I have some other chips. I don't have any donors. Like this is such a specific circuit. It's not generic in the slightest. So no, I don't have any donors. These are pretty expensive amplifiers. So any ones of these that I get come into the workshop, I will fix. You know, there won't be donors or broken for parts or anything like that. So okay. So what I want to go ahead and do now is compare voltages then across these little fucking tiny things down here. I think we're going to go ahead and compare voltages on these transistors first, see what we have. So I'm going to go ahead and bring up my notes again, and we're going to go ahead and compare what we Q48, 47, 48. So Q47, 1, 2, 3, Q48, 1, 2, 3. And then we have another 2 up here. We have Q43 and Q44. Q43, 1, 2, 3, and Q44, 1, 2, 3. Right, so Q47, this is the bad card. Power up, see what we have. I'm going to go for pin 1 being like that side. Yeah, I'm going to go for pin 1 being this side. Owen, thanks for the $4.99. Thanks so much, my dude. Really appreciate that. Every little helps with this shit. So yeah, really appreciate that kind donation there, my man. Cheers very much. So Q47, what do we have? Oh, it goes up high. Okay. Okay, so we have 24 volts on Q47 1 plus 24. On pin 2, I'm going to take this as pin 2, I think. We have a negative 7.5. And pin 3, we have positive 22.4. Okay, so Q48. Pin 1, we have positive 24.8, which is actually the same as what that other one was, 24.8. I think that's like positive rail or something, perhaps. Maybe like some VCC. Pin 2 is negative 9.3. And pin 3 is 23.7. Okay, Q43 then, this one of these up here, Q43, pin 1, is negative 24.8. Negative 24.8. So that's the supply voltage, that is. Plus minus 24.8, that's like some kind of VCC or some kind of rail. Pin 2 is negative 25.3. How is that higher? Okay. And pin 3 is negative 25.4. Yeah, that might actually be the same as negative 25.4, negative 25.3. No, yeah, it is actually different by 0.1 of a volt. Okay, 24.8, 24.9. Q4 then is Q44. Sorry, Q44 is pin 1. Negative 24.9. I'll call it 24.8 because it's the same rail. Pin 2. Negative 5.2. And pin 3. Negative 17.4. There's quite a lot of differences there. There's quite a lot going on there. So let's now attach the good known working card and compare what voltages we have on that one with the ones we've just read over here. I mean donor boards. No, unfortunately we don't. Like I say, this is very specific amp, very specific board. The only way that I'd have a donor board for this is if I had another one of these exact amps that I wasn't bothering to fix for whatever reason. Which I don't have. So. Okay, so this is now the known working board. Okay. So, known working then. Okay, so Q47, pin 1. We have 24.8, so that is a supply. So this one is the one that might be different. This is pin 2. We had negative 7.5 on the bad card. Negative 7.1, slight difference, but it's kind of similar, more similar than I thought. So now pin 3, we had negative 22, so we had 22.4. We have 17.6. Now that's actually the same as what we had on Q44. So I think that's where the issue lies. Actually, I think we might be honing in on the issue here. So Q48. Then we have positive 24.8, the same as before. Pin 2, we have negative 11.3. Okay, so that's different because we had negative 9.3 on the bad card, and on pin 3 we have 17.6. So it looks like, right, this is what it looks like. It looks like it's some kind of like comparison between voltages. This is the good card. So it looks like what we should have is on pin 3 of each of these transistors, we should have about 11.6. Because that's kind of like a trend here. So let's go ahead now up to Q43, which is this one just here. So pin 1, we have negative 24.8, which is the supply. Negative 24.8. Pin 2, we have negative 15.2. And pin 3, we have negative 25.3. Well, that's quite a bit of difference there between the bad card and the good card. Quite a bit of difference there. Okay, and last but not least, Q44, we have 24.8, negative 24.8 on pin 1, which is the supply. And then pin 2, on the bad card we have negative 5.2. On the good card we have negative 16.5. Okay, and pin 3 then, we have negative 25.3. Okay, so as you can see, quite a lot of differences here then again. So we have the bad card here is the first one, and the good card here is the second one. So you can see here some differences here between Q47. The biggest differences that we have are probably here on Q43. This negative 15 volts that we're supposed to have on pin 2, we actually have negative 25.3, and that kind of like tells me that maybe Q43 is leaking or like partially shorted inside, something like that. Even though we got good readings on the multimeter, something's a bit funky there. And we have actually wild differences on Q44. We have pin 2 again with a huge difference there in voltages. So it's either these transistors that are bad, or it's these tiny little chips down here that are bad, and these are actually kind of feeding those transistors with voltages. So what I'm going to go ahead and do is I'm going to go ahead and try and read some of these voltages on here, but I'm a bit scared to kind of short out these pins. I'm kind of, because they're so close together and shit. So right, so if I make some new notes now, we've got what is this, Q49? it's actually labelled on the board as a transistor. Q49 is the marking, which is generally the marking for its transistor, not for an IC. So it's not an integrated circuit as such. So I'm going to go ahead and make some readings now. So of the good side. So let's go 1, 2, 3, and then we've got Q50. Q50 is the other one, the 2F. Okay. Actually, I've got 6 pins here, haven't I? 4, 5, 6. Four, 5, 6. So I've got 6 pins on each of these. Just going to kind of see what differences we have here. So if I go ahead and probe pin 1. Right, 32.3. I think these are voltage regulators. 32.3 on that one. So this is good. We're going to put in here now. This is good. 32.3. Pin 2. I really must not slip my probe here. Positive. Wow, way off the freaking scale here. Positive 39.4. This is like some pretty high rail voltages here coming in. So these are definitely like some kind of voltage supply or something. Pin 3. Now you can see I'm not actually probing the chip directly. I'm probing stuff that it's connected to. So we've got 17.49. Pin 4. 32. I think these might be the things that are bad, you know, guys. Like possibly. I'm going to go ahead and remove a bunch of these parts actually and figure out what's going on between these two boards. We're getting close, I think. Pin 5. I'm going to have to probe the pin. 39. And pin 6. $17.48. Yeah, so this definitely seems like some kind of voltage supply, because look, if we take a look at this, looks like we have some kind of voltage going in, 39 there, 39, and then we have like some voltages coming out. And are these positive? Are these all positive, or are they positive and negative? Let's have a look. It's all positive, these, aren't they? Yeah, this is just all positive. So this one up here is going to be negative then. This 2F is going to be the negative equivalent of that, I imagine. So let's go ahead and do pin 1 of this one. Negative 39. Pin 2. Shit, this is tight, man. What? Negative 39 again. I think that was on that one. Pin 3. Negative 25.4. This is slightly different to what I was expecting. We've got different voltages here compared to the top board. I mean the positive chip. Pin 4. Negative 39. Wait, is this the bad board or the good board? This is the good board. Pin 5, negative 39. This is a bit different to what I was expecting, not gonna lie. And pin 6, negative 25.5. Okay. So yeah, okay, some differences there. I am expecting those to be equal between them. Not gonna lie. I thought we were gonna have kind of plus minus 17.4. But yeah, it doesn't seem to be the case. Okay, no worries, that's fine. So now we have a reference for the good one. Let's go ahead and plug the bad one in and just see what we have. We know that they're going to be different, so I think it might just be a good idea to go ahead and remove these. These are tiny little chips, so maybe I can just go ahead and swap these parts over. Maybe what I should do, guys, is I should just swap these parts over from the good board to the bad board and see what happens. So we have this one, this, this. If I swap over these 6 parts, these two, and these two, from the good board to the bad board, just to see whether the whole issue swaps sides. If it does, then we know we've got problems in that area without really having to do much digging further. So okay, let's just confirm then what we have on the bad card. Man, this is like some next rabbit hole, I swear. Okay, so Q49, pin 1. What are you saying, boy? Plus 32. So that's the same. So, pin 2. Plus 39. That's the same. Okay, cool, we're the same so far. Pin 3. Plus 19.2, that's a little different. But we know that because that was on the transistor anyway. Pin 4. Plus 32. That's the same. Pin 5. Plus 39. That's the same. So these are all coming back kind of the same. Pin 6. 20. Right, Q50. Pin 1 is probably going to be our supply, our rail, which is negative 40 or negative 39, call it that. Pin 2. Negative 39 again. Pin 3, we're supposed to have negative 25 here. Negative 17. Okay, that's interesting because that negative 17, that's kind of what we were seeing on the good one, but what the fuck? Pin 4. Negative 40. Wait, negative 41? Fuck. That's much higher than it was on the other one. Pin 5. Negative 39. And pin 6 is going to be the outputs. This is going to be different again. Pin 6. I think pin 6 seems to be the output. Negative 25. So that's actually kind of the same. So we got like these are looking kind of similar-ish. The only real main differences between these two, right, are so if I go good. So the main differences between these two ones here, right, is we've got pin 3 and pin 6 are the main ones that are different there. Again, pin 3 and pin 6 are the main ones that are different there. Guys, what we're going to do is I think I'm going to go ahead and actually remove these parts from both of these boards. I think, should I remove the chips or should I remove the transistors? I think we're going to remove these little chips, actually. I'm going to remove these little chips. And I'm just going to put them to one side. And I'm going to read the voltages on the transistors with these chips removed. And see if they then equal out. If they don't, then I'm going to remove the transistors. So I think it was the 4F on the bottom and 2F on the top, that's right. Okay, so the bad one goes up there on the bottom shelf. and 2F at the top. Okay, put those over there. Tiny little bugs, these things. They're so fucking tiny. They're like little bugs. Okay, let's get the good card. Remove them as well from here. So the good ones, I'm going to put them up top here, I think. Maybe. Oh shit, that's a bit far away. I'm going to put the good ones on the. I need to put them somewhere that I'm going to remember, and I'm going to not lose them on. I'm going to put the good ones on the left hand side. Okay, good ones on the left, bad ones on the right. Remember that, guys. Good ones on the left, bad ones on the right. Okay, cool. Good ones on the left, bad ones on the right. Good ones on the left, bad ones on the right. Right, so now that they're both removed, let's go ahead and read the voltages on the transistors, on the 4 transistors now. So these 4 transistors that are left here, and see if they're reading equal between these 2 cards. We need to get to the point where we have equal readings between these 2 cards before we can start building them back up again. Okay. So I'm going to go no bad, no good, no chip bad, no chip good. Okay, so no chip bad, so we've got Q47. Okay, 24.6, 0, 17.3. That was on Q47. So Q48, $24.6, and 2, 0, 17.3. Okay, starting to see some equilibrium now, I think. So Q43, negative 24.6. Now this should be 0, I hope, maybe. Yep, 0. This should be about negative 17, I imagine. Negative 17.4, yeah. Okay guys, I think we're actually honing in on it. These are now starting to equal out. Negative 24, 0, negative 17. Okay, negative 24, 0, negative 17. Okay, right, okay. That looks promising. We've got some equilibrium there. Look at this, look at this, look at this. Between these parts, 24.6, 0, 17, 24.6, 0, 17, 24.6, 0, 17, 24.6, 0, 17. Right, that's starting to equal out. So now that's on the bad cards. Now we have the good card, and I'm hoping and praying that that's the same. Because if it is, then we have found our problem, ladies and gentlemen, I think. And we just need to go ahead and order some of those. What am I doing? Yeah, right, swap this out. So this is now the good card. Okay, so this is now the good card. So we're hoping to see the same. Right, well, guys, what's it going to be? Oh my god, what's it going to be? Right, let's power it up. 24.6, 0, 17. 24.6, 0, 17. Yeah, boy. 24.6, 0, 17. Oh my god, that's what it is. 0.6, 0, 17. Right. Now, this could be a false positive. So this looks like that we have just found the issue in those tiny little 6-pin ICs. However, they might not actually be the problem. The problem might be voltages that are fed to them. So, with those chips removed, okay, same. So I'm just going to write down same on here. So these were all the same. These were all the same. So this is the same. Same as good. Same as bad. Same as bad. So same. Right. This is looking good so far. However, we do need to confirm the voltages on the pads for these chips are also the same between these two boards, because it could be that the chips are okay and the voltages being fed to them are different. So if we take a look at our notes here, the voltages that were different between these two chips were, it was pin 3 and pin 6, which are going to be the outputs. I imagine that these little chips actually, they're probably like just little dual transistors, like, or something like that. So pins 3 and 6. Are the differences there. Pins 3 and 6 are mostly the differences there, although pin 4 is a little bit weird on Q50. So let's just confirm that. So I'm only going to bother testing pin 3 over here. Actually, we know that pin 3 was going to be different because that was the one coming off the transistor, wasn't it? So pin 3 is 17.4. Yep. And 6 is 17.4. Negative 17.4. Negative 17.4. And I just want to check pin 4 of Q50, because that was negative 41. Oh, negative 53. Holy shit, okay. I mean, maybe that's the issue. Okay, that little thing that we saw earlier, pin 4 of Q50 is currently negative 53. I don't think that that's correct. I've got an inkling that that might not be correct. Wait, is this the good board or the bad board? Oh, this is the good board. Oh, okay, so that probably is correct then. Negative 53 on pin 4. Okay. Ah, okay, so negative 53 is everywhere, pretty much. Right, okay, negative 53 is on pin 1 and 4. And then we have negative 39 on pins 1 and 5. Is that the same on this side? Positive 50. Okay, now we have 0 volts there. Okay, I think I do just need to note these down actually, so I can remember them. Because we've got some. So this is the good cards. This is what we should be seeing. So let's just clean that off a little bit, so I get my multimeter on there a little bit easier. Oscilloscope on there a little bit easier. So push those in. So. So this is the good, no chip good, and so we have Q49 pin 1 is 27, 2, 39, pin 3 is 17, I think we know, 17, pin 4, 27, pin 5, .39, and pin 6, 17. Okay. Q50, pin 1, negative 53. Pin 2, negative 39. Pin 3, we know, I think it's negative 17, because that's the transistor. Yep, negative 17. Pin 4, negative 52, negative 53, sorry. Pin 5, should be negative 39, which it is, negative 39, and pin 6, I think, is negative 53. Nope, sorry, negative 17, negative 17. Okay, so let's just confirm those on the bad card. Because if these are now the same, then we know that the issue is those little chips. Holy shit, what a deep dive, guys. I think this has got to be one of the deepest dives I've done in quite a long time. This is preparing me for fixing the JBL Crown A6000 GTI. Who's ready for that? That's going to be a ball ache as well. Okay, so this is the bad card. So we're hoping for the same. We're hoping to read the same. Okay, so Q49, pin 1. I'm just going to go ahead and clean this off because there's some flux in the way of my probe. Okay. Q49, pin 1. 17. Oh shit, it's different. No way, what's going on? Wait, are these supposed to be different? No way. Hang on a minute. What's going on now? I'm not reading anything. These cards are definitely the same card. They're not like one for one, one for the other. Let me just make sure that I've got this thing connected properly here. Okay, pin 1 is now reading nothing, but it was reading 17. What the fuck? Hey, what's going on? Pin 1 was just reading 17, and now it appears to be reading nothing. Just checking my connections here to the board, making sure that's all good. Yeah, okay. Right, pin 1. Nothing. What? Pin 2. Plus 39. Pin 3. 17. So we're missing 27 on pin 1. Although it kind of was there a minute ago. Pin 4. We should have 27, which we're missing. Here. Pin 5. 39. Pin 6. 17. Eh? Q50. Pin 1 is 52. Pin 2 is 39. Pin 3 is 17. So these are all the same. So Q50 is correct. Yeah, Q50 is correct, but we're missing 27 volts on pin 1 and on pin 4. Even though it was kind of 17 there a minute ago, unless I was just probing the wrong pin when I first touched that. I'm sure I wasn't. I'm sure I saw 17 there just a second ago. Maybe maybe there's some dodgy resistor somewhere then. Right. Let's just plug in. I'm just going to disconnect these. Plug in the known working board again, just to confirm that that 27 volts is still there, and that something on the main board hasn't died or something. Okay, plug that back in. Yep. That's good. Okay, cool. We're good. We're good. So our 27 volts should be on pin 1, which is down here. Oh fuck! It's not. It's 0 now. Oh, what the? Oh wait. Oh, it just came. It just came to light. It just came. I think 48. It jumps up to 48 when the amp wants to activate. Oh man, this is this is confusing me the fuck. Why was it 27 there and now it's jumping up to 48 when the amp activates? 48. What the fuck, man? Right. Well, these boards are now actually acting the same then, I guess. We have 0 there to start with, and then it jumps up to 48 when the amp wants to turn on and activate. So, yeah, these are now acting the same. Let's go ahead and plug the bad board back in and just make sure that it does bump up to 48 when the amp activates. So it must be just those little ICs then. And what I can do to confirm that is I can actually swap them round. So we have the 2 ICs from the bad board and the good board in separate locations. So I can go ahead and solder, reflow those ICs, those little sort of like dual transistor things, whatever the fuck they are, those little 6-leg things. I can actually put the ones from the bad board on the good board and the ones from the good board on the bad board and power it up and just see whether the good board then becomes the bad board and the bad board then becomes the good board. Because if it does, then we know that those are the issues. So now I've reconnected the bad board, and we just want to make sure that on pin 1 there, that jumps up to 48 when the amp wants to activate. Oh, it doesn't. Oh, fuck. So the amp's powered up. It should bump up. Ah, there we go, 48. Okay, cool. So that does work. Right, so these boards are now acting the same. Poof, 48. Okay, so the boards now are behaving the same. We've removed enough components that the boards are now acting the same. So, what I want to do now is I want to solder the chips from the good board into the bad board, and I want to see if the bad board becomes the good board. So guys, I think the good chips were on the left, weren't they? Remember I said to you earlier, I think the good chips were on the left. So this is the bad board. So what I want to go ahead and do is solder the good chips onto the bad board. Let's grab my flux. Yep. Let's go ahead and drop some fresh flux on there, like so. Now I should really be using my microscope for this, but I just disassembled it and I kind of can't be bothered to put it back together again. So let's get this little chip. Now, are you the 2F or are you the 4? Okay, this one here is the 2F. Oh shit, what was pin 1? Oh, guys. Oh, what was pin 1? Fuck. Did pin 1 go like that? With the 2F there like that? Oh, I can't remember. Can anybody remember what the orientation was? Or maybe skip back in the stream. I think that the bottom of the 2, like the underside of the 2 is pin 1. I think that's how that goes. I shouldn't take a note of that. Can someone just quickly skip back in the stream maybe and see if you can, or if you can remember. But I think that's how it is. I could take a look at one of the remaining good boards, because this amp is a 4-channel amplifier, so I've actually got 2 good boards. I've got 2 spare good boards again for other channels that I could just take a quick look at, but I don't want to. And also, they might be really hard to see. Right, let me skip back in the stream and see if I can see. Where are we? We've got the microscope. Shit, where was the bit where I got the microscope out? So far back? Oh yeah, it's back here, I think. Shit, was it really that long ago? Jesus. Ah, here we go, okay. See that? Okay, 4F. 4F. Shit, okay, yeah. So the bottom of the 4 is on the dot, and I think the 2F is going to be the same. Will that focus? 4F, and then do I scoot down to look at the 2F? I think that should be the same with the bottom of the number on the pin 1. Yeah, looks like it. Yeah. It is. That is that way around. Okay, excellent stuff. Okay, cool. Let's go ahead and resolder that on then. So these are the good chips going on the bad board. This is some tiny ass fucking soldering, man. Okay, it's almost on. Just need a little bit more flux and just reflow it in place. Give it a little nudge. There we go. That's good, that's good, that's good. Sorry if you couldn't see that, my head gets in the way, I know. Just trying to look down on it enough. Okay, cool, yeah, that one's in. So then this one here is the 4F. Which is going this way around, I believe. I can't really make out those markings super well. I think I can just about make it out. Yeah, I can just about make it out enough. Okay, cool. Right, they're now soldered back on. We need to wait for that to cool down. Naturally, I don't want to cool it down too quick to give it some kind of thermal shock. So yeah, they're both now soldered on in the correct orientation. That's cool. So they are the good chips on the bad board. So now what we're looking to do is we're looking to look at our list here, okay, and we want to check these 4 transistors, okay, so these values here are the ones with the chips in. So these values here were the original bad board readings, yeah, on this side here, this column here. So we should now hopefully have these voltage readings from the good board now appear on our bad board, if those chips are the issue. Okay, moment of truth then. We are looking for, on Q47, we are looking for 24, -7, and 17. What's it going to be? Fuck, I'm so scared. 24, -7, 17. Yes! Fucking yes! Okay. Yes. That is now the readings that were on the good board are now on the bad board after swapping those chips around. Right. Let's try Q48. So we need 24 -11, 17. 24 -11, 17. Holy shit, yes. Holy shit, yes. Q44. We need minus 24, minus 16, minus 25. Minus 24, minus 16, minus 25, 43, minus 24, minus 16, 15. Yes! Okay, we have the readings that were coming from the good board are now on the bad board. So, provided that was the only issue, if I start rebuilding the bad board up with some of the components now, putting everything back, TL072C, putting that back, putting everything back, that might turn the bad board into the good board. Which then means that we just need to order those parts and put them onto what was the good board and build that one back up again. Holy shit, okay. Right. What do I want to do now? I think it's time. I think this is a good point to end the stream. So, I was hoping that... I think we have sussed the issue. I think we have figured out what the problem was on these. So, I was hoping to have this fixed by this stream, but didn't know it was going to go that deep. Didn't know it was going to dive that deep. But... now we have figured out that those parts, after swapping them from the good board to the bad board, have swapped the voltage readings around on these boards. I think that that's probably the issue. So now all it's going to take is to start rebuilding these boards back together with the parts, the other parts we removed, like the op amps and stuff like that, and see whether stuff starts coming back to life. I might just go ahead and order a bunch of new parts, like a bunch of new 833s, a bunch of new 072Cs, just so we're not putting bad parts back in, I guess. Yeah, I might, like, I don't know if those op amps are okay that we removed, because they could have just been having bad voltage readings on them as a result of this circuit being bad, the one that we've just found, or they could have had bad voltage readings on them because they were fucked as well. So I think, do I want to leave it here now, or do I want to go ahead and, what's that? That's the bad 833, and this is the good 833 up here somewhere. This is the good 833 up here, right? So what I'm going to do then is I'm going to put the bad 83. Do I want to do that? Right, let's just be quickly before I go. I want to have a look at these two 833s. I want to compare them on the multimeter, because what I don't want to do is I don't want to put the bad 833 into the now good board, well, there was once a bad board, and kill. Maybe it's the 833 that was killing those little chips. So I don't want to do that. So, but just to confirm, what I want to do is I want to take the two 833s here. So this one on the left hand side is bad, and this one on the right hand side was from the good. So that one's from the bad, that one's from the good. So let's just compare some multimeter readings between these two and see if there's any wild differences. Now I'm probably going to get differences between, if they are bad, I'm going to get differences between the VCC pins and other stuff. So let's just read between the two VCC pins right quick. So this is the bad one. This is one from the bad card. So we have sort of 18 there on the screen, sort of fluctuating a little bit with the probes that way around. If we flip her around, we have, okay, so on the bad chip we have between the two VCCs we have 760. Okay, on the good one, between the two VCCs, what do we have? That's the same. Okay, so how about between that VCC and these two middles? We don't have anything. So we shouldn't have any reading between that and that. So let's confirm that on the one from the bad card. Oh shit. We have 802, 800. Oh, okay, so that 833 could actually be fucked. 1820 and nothing. You see, the problem is because these little op amps, right, they can like sort of, the silicon and stuff can sort of turn on and off as you're probing it with the multimeter. So you have to do some probe flipping and do some recomparisons every time, because the chips just could be in different states. 18. So that's now reading the same as the other one. So if I flip the probes, okay, no, that's reading the same now. Okay, see, that's what I mean, right? So it looked like these two were different, but then just from flipping the probes and reading them again, now they both read the same. So the chips can be in different states inside, which will kind of throw you off and give you false readings and stuff. So a bit of a pain in the arse when that happens, but yeah, it can happen. So we've got 933 between, I'm just probing these like 4 pins here. I'm just like connecting all 4 pins together just to kind of, like, we're not looking for accurate readings, we're just looking for comparisons. We're looking for the stuff that's the same. Okay, it's, what's that, 972? And what's this one? 973. Yeah, that's about the same. Flip the probes. So I think that these are fine. I think that these are both fine. Nothing that way round. Nothing that way round. 978. Yeah. Wait, 798. 798. Yeah. I think that these are fine because we're getting consistent readings now between these two. 864. Yeah. We're getting consistent readings now between these two. So I think that these op amps are probably fine. So it's likely then that all of the other components that we took off between these two boards are actually probably okay. You know what, I'm just going to quickly, I was supposed to stop the stream here at 10, but just very quickly, I'm just going to go ahead and load this 833 back onto this was the bad board. I'm going to go ahead and actually load the bad 883 that was from this bad board back onto here again and see if the voltages on this 833 turn into the ones that were on the good board. Because that will tell me then that this 833 is actually okay, yeah? Put that on there, put some flux. I'm going to preheat the board a little bit here, so I don't have to, because op amps can be very heat sensitive, so I don't want to heat them unnecessarily, so I'm just going to preheat the board a little bit first. Yeah, Toloco16 said, yeah, maybe just one of those chips is bad. I absolutely agree with you. But I might as well replace both of them anyway at the same time. If I've got to order some new parts, I might as well go ahead and replace both of them anyway. Right, so let's put this 833 in here. My hands are kind of shaking a bit more than usual. I think I'm a bit excited, you know, guys. I think I'm a bit overexcited. My hands are much more shaky than usual. Okay, deep breath. Okay, that's cool. I'm getting all worked up. Okay, that's better. That's better. That's so much better. I can hold this so much more still now. Don't know your boy gets excited about these repairs and shit, man. Standard procedure. Okay, so that's the 833. Back in the board. Wait for it to cool down for a minute. Just while we're waiting for it to cool down, let's take a look at our notes. We had the 883, which is U11. So, wait, hang on. I'm a bit confused at my markings here. The U11. Shit, I didn't get readings for U11 with... I didn't get readings for U11 with the part in, did I? I got readings with the part out. I didn't get readings with the part in, so there's not much I can do there. What I can do though is I can get readings of U8 and U4. So yeah, that's the next thing that I've got to compare. So U4, I've got U4 with the part in and U4 with no part. Damn, I didn't write down what the voltages were. Oh no, wait, yeah, U4 no part. So U4 no part, okay. Wait, is that what I had, or is that what... Oh shit, so I don't know if that's the good board or the bad board. So what I think I need to do then is, because unfortunately my note taking has been pretty poor. I should have noted down good board and bad board, because the only thing that I've got now next to compare is U4 with the op amp fitted. That's the only thing I've got next to compare, and I think U4 and U8 were both fitted at the time, so I think I'm going to have to go ahead and fit U4 and U8 again, so that I've actually got something to compare it to as we start fitting these parts back in. And it's getting a bit late now. It's 10:30. I was not meant to be streaming past 10, so I'm going to leave it here. But this is a real deal. This is a real cliffhanger. So this is really exciting shit. So guys, get subscribed. I hope you're enjoying this. I hope you're as excited as I am with the progress on this one. I think we finally found it and finally made it. Just before I leave though, I am just going to really quickly see whether we can find out what this is. What the heck is this 2F and 4F? I think the package on this is... what is the package on this? It's like an SOT... No, it's even smaller than that. Shit, man, I don't even know. Guys, what is this? What is this? I'm going to take a look at a schematic real quick. But I think because I can see this bit of finding out what parts these are taking a little bit of time. I'm actually going to do this off stream because I do want to head out right now. Head off the stream just now. So what I'm going to do is off stream in my free time over the next few days, I'm going to try and find out what those parts are. Get some of those ordered, maybe try and find a schematic somewhere, find out what the 2F and the 4F 6-pin ICs actually are. They're marked as Q, which means that they're likely to be transistors of some kind rather than an IC, but they could be an IC, it could just be Rockford's marking. SOT236, I think they're smaller than that. They're actually smaller than, because basically the SOT23 would mean that the package is the same size as the SOT23s, you know, the little transistor, the 3-pin, but with 6 legs. But these aren't. These are actually they're even smaller. They're much smaller. You can see here on the camera, you can see that this right here. Wait, here we go. This right here is an SOT23 package part. So if it was the SOT236, it would be this size, but with 6 pins. But it's actually way smaller. So I'm going to have to try and figure out what that part is. Prolux Electronics says dual transistor. That's what I think as well, just because it's marked as Q, which is the marking for transistor. Everything else on this board that is an integrated circuit of some kind is marked as a U, U10, U11, U8, etc. So I think that, yeah, like you say, I think it's a dual transistor. I've just got to try and do some work and dig out exactly what dual transistor it is. I hope I can figure it out. Order those parts, and then we can start loading up these boards back up with the LM833s, the the TL072Cs, and all the other components, so that we can get these boards fitted back to the amplifier and hopefully have all 4 channels working with their protection circuits working as well. Guys, it's been an absolute pleasure. Thank you so much for sticking with me with this repair. It's a really interesting one. I'm learning a bunch. I hope you're learning a bunch too. Troubleshooting methods are good. Like the amount of time I've spent on this repair is probably not worth the amp, but I'm enjoying making this content. I'm enjoying this process of figuring this one out. So I'm willing to take the hit on the time that this is taking just to kind of learn a bit and make this content for you guys. So holy shit, Taloko comes in the live chat right up here with some part numbers, as does Opossum. With a bunch of part numbers in here. Are your small 6 pins maybe this type of circuit? Warren Mann says as well. Okay, thank you so much guys for these suggestions. I'm going to go ahead and Google these. Let me take a quick screenshot of this. I'm going to go ahead and Google these parts and see if any of them fit the bill with what I need. Paint, MS Paint, paste that in there. So I can go ahead and Google these and see whether any of them fit with the circuit. But I'm going to try and get a Rockford schematic that uses these parts as well, just so I can get the exact correct part, just to make sure I get the exact right part. But at least I know now what the voltages should be on the pins, so if I buy some parts and they're not right, then I'll know they're not right because the voltages will be incorrect on them. So yeah, guys, thanks for sticking with me. Been a pleasure. I'll see you maybe tomorrow for another stream. I like streaming over the weekend because a lot of you guys jump on board, so it's good fun. Yeah, we'll continue with this one and see how it goes. Take it easy, guys. Have a great weekend. See you next time.